Hello, 7th grade, and welcome to Lesson 4-9, the last lesson of Chapter 4 on scientific notation. In tonight's lesson, we have two objectives. First, you will be able to write and evaluate numbers in scientific notation, and secondly, you will be able to calculate with scientific notation. Now, here as a warm-up, we have a few expressions that we want to write as a single exponent, meaning we don't have to solve it, we just have to write it as an exponent. And all of these are great review, really, for what we've worked on. Now, again, remember when we're multiplying exponents with the same base, what you end up doing is adding the exponents. So here, 10 to the third times 10 to the fifth, well, is 3 plus 5, which is 10 to the eighth. And again, you could do this for all of them. Here you get 10 to the 7th plus 9, which is 10 to the 16th. And so on. Here, 10 to the 5th plus a negative 3. Well, the signs are different, so you subtract them. 5 minus 3 is 2, and 5's bigger, and so on. So that's what we've worked on in the past. Now we're going to jump right into scientific notation. When we talk about scientific notation, that's when we write numbers using powers of 10. And this is with product of two factors. We write them as a product of two factors. For example, I have really a table listed below that I'm just outlining in red. All right, so we did the first one for you. We have 5 times 10 to the 4th power. Well, really, when we talk about 10 to the 4th power, that's 10 times 10 times 10 times 10, which is really 10,000. So 5 times 10,000 is 50,000. Or here we have 5 times 10 squared, which is 10 squared is 100. 5 times 100 is 500. Here we have 5 times 10 to the 0th power. Oh, we just talked about this in the last lesson. Any number to the 0th power is 1. So 5 times 1 is 5. And then here we have a negative exponent, 5 times 10 to the negative 1st power, which is really 1/10. 5 times 1/10 is 5/10. This first part here is all scientific notation because we wrote it with powers of 10 of two factors. We have 5 times 10 to the 4th. Those are our two factors. All right, so really we could write this one now. 7,500,000 is really the same thing as 7.5 times 10 to the, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 to the positive 9th power. That's how you'd write it as an exponent. Because again, you could divide this number by 100 million, and that's what you'd get. You'd get 7.5. So we're going to first talk about how to write something in scientific notation, and this is with our first example. About 6,300,000 people visited the Eiffel Tower in the year 2000. Write this number in scientific notation. Well, we need to first see the number we're dealing with, 6,300,000. Now, what you do is you move the decimal point to get a decimal that's bigger than 1 but less than 10. So, we need to figure out where we could put the decimal to have a number that's bigger than 1 but less than 10. And I'm going to tell you this, it's usually between any number that's not a 0. So, 6.3, that's bigger than 1, but it's less than 10. I couldn't write it as 63 because that's bigger than 10. And I certainly couldn't write it as 6300ths because that's smaller than 1. So here, we switch this to 6.3. All right, that's my first factor. Now I know I'm going to multiply it by 10, but I have to figure out how many times. And what you do is I put my decimal right there. You count over how many hops that is. 1, 2, 3, 4, 5, 6. So 6,300,000 is the same thing as 6 3/10 times 10 to the 6th power. Whenever you move the decimal this way, it's going to be positive. If you move the decimal that way, it's negative. This is a key point that you'll want to remember for tonight's lesson. Here we have this one. The world's largest tree has been named General Sherman. Its weight in pounds is about 2,770,000. Write this number in scientific notation. Well, again, we need to figure out where our decimal goes. We want a number bigger than 1 but less than 10. Here, is where it'd go, 2 and 77 hundredths. 2.77. And again, you look at any number that isn't a 0 in here, that are together here. And we had 277 as our digits, or 277 as our digits. And we need to get a number that was between 1 and 10. So that would be our only option. That's one factor. Then we have times 10 to the 1, 2, 3, 4, 5, 6th power. So this number is 2 and 77 hundredths times 10 to the 6th power. Now this time, we have this digit. We have 37 hundred thousandths, I believe. So we need to figure out where the decimal should go this time to write this in scientific notation. Well, again, you need to look at the digits that aren't zeros here, which are the 3 and 7. All right. Now, I already told you if we go this way, it's a plus when you move the decimal. If you go that way, it's a minus with the exponent. I want you to try to figure this one out. Look at where the decimal's placed now, and we need to get it somewhere with the 37, but we need a number between 1 and 10. So first, place a decimal where you think it goes. So if you try to place it, let's see, if I put it here, I get 37. If I put it in here, I get 3.7. And then here I'd get 37. Well, I think the decimal will have to go there. So I know I have 3.7. I know I have times 10 to something power. So if I started here and I have to move this way, find out what my exponent would be. Go ahead and do that now. So if we check this one then, it has to go 1, 2, 3, 4 hops. Now we're going 4 hops to the right, which is a minus 4. Again, if you move this way, it's a minus exponent. If you move that way, it's a plus exponent. All right, so we talked about how to write things in scientific notation. Now we're going to work backwards. We're going to change an expression from scientific notation to digits or number form. When we do that, it's called standard form. That's how we usually write our numbers, in standard form. So we're going to switch from scientific to standard form. Now, write each number in standard notation. Again, we could do that one way. We could do 3.6 times 10 to the 4th. Well, 10 to the 4th is 10 times 10 times 10 times 10. Well, 10 times 10 is 100, 1,000, 10,000. So you could do it that way, and you would get you should get 36,000. All right? You could do it that one way. Use the calculator, multiply out 3.6 times 10,000. Yeah, you'd get 36,000. Or we can use it the other way. Again, keeping this in mind. If you go that way, it's plus. If you go that way, it's minus. So 3.6. Now we have 10 to the positive 4th. So we know that this is a positive number, meaning the decimal actually goes backwards. So we make 4 hops. 2, 3, 4. And you get 36,000. So same answer. All right. Oops. Now we have B here. Once I get all of this moved over. There we go. All right. We have 7 and 2/10 times 10 to the negative 3rd. Well, again, we could start with our exponent here, 7.2. Now, again, we talked about how when we moved it this way, it's negative. Except when you do standard form, it kind of flips around. All right? So, here we have a negative exponent, meaning it's a decimal number. So we need to go 3 hops to the left. 1, 2, 3. Get my decimal and fill in any empty hops with zeros. You get 0.0072 or 72 10,000ths. All right. Again, you could do it however you wanted to, if you like the first way or the second way better. Now we need to write these ones in scientific notation. So we're flipping the lesson again a little bit. We have here some numbers that have started to be written in standard form, but they're not quite right. For example, A, we have 107 thousandths times 10 to the 12th. Well, we have 2 factors, except this factor to start with isn't between 0 and 1. So they have the decimal in the wrong place, is really what they're showing us here. So I need to switch where the decimal is in order to get it written in scientific notation. Well, I have a few options. I could put it there, I could put it there, or I could put it there. But again, if it needs to be between 1 and 10, the only option is really rewriting it as 1 and 7/100ths. So putting the decimal between the 1 and 0. All right. Now, what we ended up doing, though, was going one hop over. So we added one more decimal, or times 10, to ours. So really what we have is 1 and 7/100ths times 10, well, 12 plus 1 to the 13th power. Because, again, we had to move the decimal 1 to the right. So here we do really the same idea. We have 515 and 2/10ths. And we have times 10 to the -4th. Well, again, this isn't written with the number between 1 and 10. So I need to switch where the decimal is. Well, it was there. It should be right here, because then I get 5 and 152 thousandths. So I have to move it over this way too. 1, 2. Now remember, if you go this way, you subtract. So we subtracted 2 more hops. And we get 5.152 times 10 to the -6th. There we go. Now, last piece of the lesson, I believe, today is comparing and ordering numbers. So again, we have numbers in what's supposed to be scientific notation. We have 35 thousandths times 10 to the 4th, 710 times 10 to the -1st, and 69 hundredths times 10 to the 2nd. And we need to order them from least to greatest. Now, there are a couple things you need to do here, and I have it written in blue. First, you need to rewrite each number in scientific notation, because these are like the ones from before. They're not quite right. They're not exactly written in scientific notation. So that's what we need to do first. Then we order them. All right, so I go ahead and start with this first one. I have 0.035 times 10 to the 4th. Well, in order to get a number between 1 and 10, I have to figure out where to put my decimal. If I put it here, I have 35 hundredths. That's not quite right. Oh, but if I put it between the 3 and 5, I have 3 and 5/10ths. That is right. So 3 and 5/10ths times 10, and then I have to count where it was originally to where it is now. And I added 2 hops. All right, so we have 4 plus 2, which is 6. So this one is 3 and 5/10ths times 10 to the 6th power. Now I'm going to do the same thing to the next one. I have 710 times 10 to the -1st power. Well, I need to figure out where to put my decimal. Right now they don't show it, so that tells me this 710 is a whole number, and it's in the back. So I need to put it between the 7 and 1 to get 7 and 1/10ths. And I know I'm going to have times 10 to something. Well, 1, 2. I add 2. So -1 plus 2. Well, those are opposite signs. One's negative, one's positive. So I subtract them. 2 minus 1 is 1, and 2 is bigger, so it's a positive. So I get 7.1 times 10 to the +1st power. All right, and then finally I have 0.69, or 69 hundredths, times 10 to the 2nd power. All right, so here I have 69 hundredths. That's not between 1 and 10, but if I move the decimal here, I have 6 and 9/10ths. That is between 1 and 10. All right, and then I have to move it over to the right 1. Well, if you move backwards, you actually subtract. So 2 minus 1 is 1. So I get 6 and 9/10ths times 10 to the 1st power. There we go. I rewrote them all in scientific notation. Now B, we have to order them with the powers of tens from least to greatest. So here it's really nice for the most part. You can look at the powers, and the smaller the power is, the smaller the number itself is. So here we have 7 times 1 times 10 to the 1st power. And I'm just rewriting them down here. 6.9 times 10 to the 1st power. And 3 and 5/10ths times 10 to the 6th power. So looking at this, well, 10 to the 6th is greatest power. So I know that's actually the largest number. But the problem runs into when we have the same power. Here, both of these are 1s. When the powers are the same, that's when you look at the number in front. Well, what's bigger, 6 and 9/10ths or 7 and 1/10ths? Well, 7 1/10. So my smallest number is 6 9/10 times 10 to the first power. Then it's 7 1/10 times 10 to the first power. Then it's that 3 5/10 times 10 to the sixth power. So that would be our answer if they're written correctly in scientific notation. However, they weren't written in scientific notation. So we need to go back up to the original and rewrite those numbers. Well, 6 9/10 was first written as 69 hundredths times 10 to the second power. Then I had the 710 times 10 to the negative first power. Then I had, all right, um, 0.035 times 10 to the, and I'm just taking a look because I think I made an error here. I moved backwards 2, so this should have been minus. So I should have subtracted those, so that was my fault. 4 minus 2 is 2. So here this should be to the second power. And you'd get times 10 to the fourth. Again, it didn't really affect it because that power was still larger than the first ones. All right. And then we have calculating with scientific notation. So you can multiply numbers in scientific notation using the rules for multiplying powers with the same bases. So really what you're going to do here is in number 6. I'm going to show you how it works. You're going to multiply 4 times 10 to the negative 6th power and 7 times 10 to the 9th power and express the result in scientific notation. But what you do is first look at the numbers they're multiplying together. 4 and 7. Well, you multiply them. 4 times 7 is 28. All right, and then we have times 10. Here, the bases are the same. When the bases are the same, you add the exponents. So we end up with 28 times 10 to the negative 6 plus 9 power. Well, I'm going to rewrite that. 28 times 10 to, let's see, 9 and negative 6. They're different signs, so I subtract them. 9 minus 6 is 3, and 9's bigger and it's positive, so it'd be a positive 3. Now this looks mighty good and fine, except if you look at that front number, it's a 28. That's much larger than a number between 1 and 10. So what we have to do is add a decimal point in here. So if I had to switch it from 28 to 2 8/10, I hopped over that way 1, so I add 1. So 2.8 times 10 to the 3 plus 1 is 4, fourth power. All right, and here's another example of it. Scientists find a woolly mammoth fossil that is 2 times 10 to the 4th years old. They believe that Earth is about 2 3/10 times 10 to the 5th times as old as this fossil. How old do they believe the Earth is? Well, it's the same idea of the one we just did. You're going to multiply together the numbers in front, the first factors. So 2 3/10 times 2. All right, and you could multiply that out. And you get, let's see, and I count my hops over, 2. You get really 4 6/10. And then we get times 10 to, now we look at the bases. I have a base of 4, and I have a base, or excuse me, a power of 4 and a power of 5. So add them together. 4 6/10 times 10 to the 9th power. Now here, I look, my number in front is between 1 and 10. So that's actually my answer. No other work required. And it is a word problem, so I should probably write years old. All right, that's your lesson today. So we talked a lot about different things you can do with scientific notation today. We talked about how to write numbers in scientific notation. And again, the main idea is if you go this way, add the powers. If it goes this way, the exponent or power is a negative. Writing in scientific notation, and then ordering from least to greatest, and then multiplying exponents. And multiplying the numbers in front to rewrite it in scientific notation. That's your lesson for tonight. I will see you tomorrow. Bye-bye.